Hi, third graders. Back today for our math lesson. And I started off on the wrong page, so let's turn back. We're going to review what we talked about yesterday. All right, so we have been talking about locating points on the number line, and we see that our number line is going more than one. Okay, or greater than one. Notice when we are putting fractions on the number line that are greater than one, we know that we're dealing with more than one shape. Okay, if you recall earlier in the week, we were dealing with circles, we drew rectangles, we've got more than one fraction strip. So, yesterday I left you with the question of what do you notice about the relationship between these whole numbers on the number line and these fractions that we're placing on there, and specifically these denominators. So what do the whole number 2, this denominator 2, and the 4 have in common? Okay, or what's the relationship between those numbers, and how can they help you make sure that you're getting your fractions in the correct spot? So let's take a look. So today, we are going to still kind of work with the same thing. We are still trying to get good at locating fractions on the number line, just a given point. Okay, so today we're going to look at the fractions 8/2 and 11/4. And again, I want you to think about the relationship you're seeing between this denominator when it gets placed on the number line and the whole number. Okay, so let's take a look. So, first of all, let's not forget, this denominator, this 2, tells me how many pieces or parts I'm going to break my number line into. And I'm going to break my number line into halves. Now, I need 8 total halves. Okay, so first of all, I'm going to mark off my endpoints. I know that I'm going to have start at 0 and 1. Okay. Okay, so we're going to go greater than 2 today, and I'll tell you we're probably even going to need to add another number on here, but we're going to kind of see how this number right here can help us figure out how many numbers we need, actually this whole thing can help us figure out how many whole numbers we need to put on our number line. Okay, so first of all, we're going to partition in half. Okay, so I know that I need to break this number line in half. So I need 8 of these little pieces right here. So here's 1, 2, need 6 more. Gonna partition again to make another half. 3, 4, gotta partition again. 5, 6, and I'm going to partition one more time. 7, 8. Now, how did I know that I needed to create a number line to 4 to get this number line partitioned into 8 halves? Well, let's first put my fractions on the number line, but I want you to pay really close attention to what fractions are falling at these whole numbers right here. So I'm talking about the 0, the 1, the 2, the 3, the 4. I want you to pay really close attention to what fractions I'm putting here and then what relationship you think they have in order with one another. Okay, so of course at 0, we know we are at 0 halves. If we move over to our next partition, we have 1/2. If we move over here to our 1, we have 2 halves. Okay, so think about what does 2, 2, and 1, what do those numbers have in common? Okay, or what's the relationship? We know our next partition is 3 halves. Then if we move over to the 2, we've got 4 halves. Okay, here we've got our next one, we would be at 5 halves. Then pay attention to what's going right here at my 3 is 6 halves. So what do 6, 2, and 3 all have in common? And I'm gonna do 7 halves, and then here I am at 4 with 8 halves. And again, pay attention to 4, 2, and 8. What do those numbers have in common? So how did I know I needed to partition my number line to 4? How come I didn't stop at 3? How come I didn't go on to 5? Well, I knew that because I can use multiplication and division to help me figure out where this fraction is going to fall on the number line. Okay, so if you notice, I asked you to observe what the relationship between 8, 2, and 4 was. Well, I can, first of all, if I'm just looking at this fraction, set this up as a division problem. If I have 8 and I divide it by 2, I know that it's going to be 4. Okay, that's how I knew to put my fraction there. Okay, I can also double check my work and say, hey, I've got this 4 here, and I know if I multiply it by 2, I should have 8. I can double check to make sure that my fractions are in the same spot. Same thing with this 3. I can just double check that this fraction is correctly placed here, because if I divide 6 into 2 groups, I would have 3 in each group. Or if I multiplied 3 by 2, it would give me 6. Same thing for this 2. Okay, so 2 times 2 is 4, or 4 divided by 2 is 2. Okay, so depending on what information you have, will kind of determine if you need to use multiplication or if you need to use division. So 11/4. Okay, now let's think about that. Based on what information you know, how far do you think I need to make my number line to? Okay, so I'm going to use division to figure that out. Okay, so how I'm figuring this out is 11 divided by 4. Well, that does not divide evenly. So what I need to think about is what number can I divide 4 by to get to as close to 11 as possible. But of course, I need to be bigger than 11 because I need 11/4. So I can't have 10/4 or 9/4 or 8/4 because I need 11. So my number has to be bigger than 11. Well, I know that if I multiply 4 by 3, I can tell you the fraction that's going to fall here is going to be 12/4. Okay, because 4 times 3 is 12. So let's go ahead and mark off all our fourths and mark off our fractions to see if I'm correct. Okay, and how this strategy can help you. Okay, don't forget, I need to partition each one of these little spots into fourths. Oops, and this one is a little larger than the others, but that's okay. All right, now let's start placing our fractions on this number line. Okay, so I know that if I'm at 0, I have 0/4. Okay, then I'm at 1/4. Then 2/4. 3/4, and of course when I get to 1, I have 4/4. Okay, 1 times 4 is 4, or if I divide 4 by 4, it is one group. Okay, so I'm going to skip over to this 2 because I can ask myself, 2 times 4 would place what fraction here? And I know that my number line is broken into fourths, so of course my denominator is not going to change. So 2 times 4 is 8. Okay, again, moving on to this 3. Excuse me. I know that my shape is still broken into fourths, so all I need to ask myself is 3 times 4 is 12. Well, I'm looking for 11/4, so all I need to say is, hey, I know that 11 is 1 less than 12, so 11/4 would be right here. Okay, so I did not have to sit here and label every single spot on a number line. Now, if you're still at the point where you need to do that, that is perfectly fine. But this is just a quick and easy strategy that you can use, especially when you start getting into the 6th and the 8th and partitioning. And you can also double check that you're correct once you get these fractions placed on here to make sure that everything is partitioned in the correct partition correctly and all your fractions are placed correctly. So see you guys next time. Bye.